Welcome to The Explainer, brought to you by Forge College. If you've been following along with our Ethereum, Dev Stacks, and Frameworks track, you know we're right in the thick of the Hardhat Fundamentals course. Today, we're stepping into the workshop to tackle exactly what's on the title, writing a basic Solidity contract in a Hardhat project. Let's get right into it. Now that we've officially cleared our calendars from that previous lesson on scheduling and conflict detection, we can finally roll up our sleeves and face the blank screen. Seriously, no more theory, no more setup delays. It's time to actually build something tangible, and we're going to do it step by step right here on our beige drafting table. Here's our architectural schematic for today's agenda. We'll start with a welcome to the workshop, move on to drafting the contract skeleton, organizing the project layout, going through the compilation process, and finally, inspecting your final artifact. Section 1. Drafting the contract skeleton, building the simple storage engine block. All right, let's look at the raw materials for SimpleStorage.sol. This is our basic engine block, right? We're keeping it intentionally small so that when we compile it, we're focusing purely on the file structure, the typing, and the core semantics. But before we build any logic, we absolutely must add our SPDX license identifier. Think of this as the standard safety stamp on your patent paper. In the Web3 space, open source is a massive deal, but compilers and tools need to know exactly how your code can be legally shared. By putting something like SPDX-license-identifier equals MIT right at the very top, penned in that dark green ink you see there, you're telling the world and the compiler that your blueprint is open for business. Plus, it prevents those annoying warning messages right out of the gate. Next up, the pragma. This is crucial because it ensures we're using the exact right set of tools for our workshop. You see, Solidity evolves incredibly fast. If you write a blueprint meant for a 2023 set of tools, but hand it over to a 2018 machine, things are definitely going to break. So, by stating pragma solidity at 0.8.17, you're explicitly telling the Hardhat tools, hey, only use version 0.8.17 or higher to read this document. Make sense? Okay, with the paperwork out of the way, let's sketch out that core engine block. First, we need a place to store our data, so we declare a state variable, uint256 private value. That just means we want to store an unsigned integer, a positive number, privately. Next up, we have a constructor. Think of the constructor like an initialization sequence that runs exactly once when the contract is deployed. It takes an initial value and assigns it to our state variable. And finally, we add a simple read function to check the value and a write function to update it later. It's minimal, it's elegant, and it's mechanically sound. Section 2. Organizing the project layout. Where does the blueprint go? So, a beautiful blueprint is completely useless if it's lost in a messy workshop, right? If you just leave your code lying around on the floor, the Hardhat compiler isn't going to have a clue where to find it. As you can see mapped out here, your SimpleStorage.sol file lives right inside the contracts directory. That's basically your compiler inbox. Then, the scripts folder is where you'll put instructions for deploying this contract later on. Your tool settings, like confirming your compiler version matches your pragma, live in Hardhat config.js. And finally, the artifacts folder is your outbox. That's where the finished, auto-generated machine code will eventually pop out. Keep this specific folder structure pristine, guys. It really is the secret to a stress-free developer experience. Section 3. The compilation process. Meeting the building inspector. To call the inspector over, it's an incredibly simple 3-step process. First, open your terminal right at the root of your project, exactly where your hardhat.config.js is located. Second, if you haven't already, just run npm install to make sure all your node modules and dependencies are present and accounted for. And third, the magic command. Execute npx hardhat compile, written right there in bright orange ink. This tells Hardhat to look in your contracts folder, read your Solidity files, and check them for structural integrity. Now, if this strict building inspector blows the whistle and throws a wall of red error text at you, don't panic. Seriously, he's just being pedantic. It's almost always a common, easy-to-fix failure mode. The most frequent one is a pragma mismatch, which just means the version you wrote in your file doesn't match the version configured in hardhat config.js. You just update one to match the other. Another classic is the missing semicolon, literally like forgetting to tighten a tiny bolt at the end of a line of code. Or you might have omitted visibility, meaning you simply forgot to tell the compiler if a function should be public or private. The compiler will tell you exactly which line is broken, so read the error, grab your wrench, and fix it. Once you've matched your versions, tightened all those semicolons, and declared your visibility, you just run the command again. And boom, the inspector gives you the green light with this beautiful success message, compiled one Solidity file successfully. Honestly, there is absolutely no better feeling in Web3 development than seeing a clean compile. Section 4. Inspecting your final artifact, the approved patent. So what actually got created during that approval process? On the left side here, we have our human-readable source file, SimpleStorage.sol. It defines our logic, our state variables, and our rules. But it fundamentally requires compilation because, well, the Ethereum blockchain cannot read English. On the right, we have our artifact. This is the machine-readable JSON format containing your application binary interface, or ABI, and your bytecode. This artifact exposes the interfaces that your web applications will actually use to talk to the contract. This right here is the raw material that's actually ready for blockchain deployment. But if we want to actually use this new artifact to build out front-end applications or use it in the other amazing courses Forge College offers, where do we actually find it? Where exactly did Hardhat hide our newly stamped patent? Well, you'll find your ABI and bytecode neatly filed away in that artifacts folder we talked about earlier. Specifically, if you look under artifacts/contracts/simplestorage.sol/, you'll see a file named SimpleStorage.json. Now, you don't need to read or manually edit this JSON file. It honestly looks like a giant wall of computer gibberish, but its very existence proves your code is logically sound, successfully compiled, and ready for the next phase of development. I want you to keep this key principle in mind. Treat the current contract as a stable baseline for testing and further development. You've just created a perfect, pristine artifact. In our upcoming explainers, we're going to take this exact simple storage artifact, use it to write automated tests, and deploy it to a local blockchain network. Because we kept it simple and clean today, we know the foundation is rock solid. So the big question I'll leave you with is this. Are you ready to decode your artifact's bytecode, understand how it maps back to your original source code, and actually deploy it to a live network? Because that is exactly what we're tackling next. To explore more about this topic, dive into advanced Web3 concepts, and join a community of builders, be sure to visit Forge.college. Thanks so much for tuning into this explainer, and I'll catch you in the next workshop.